Imagine, for a moment, standing at the summit of the greatest intellectual mountain imaginable. Not a peak of rock and ice, but one of pure thought, of abstract patterns and universal truths. This is the ascent to mastering all of mathematics. Every theorem, every axiom, every conjecture, from the simple elegance of arithmetic to the mind-bending complexities of multidimensional geometry and quantum field theory. It's a concept so profound it borders on the divine, a quest to hold the entire logical framework of the cosmos within a single human mind. What would it mean to achieve such a feat? This isn't just about being good at numbers, it's about speaking the native language of the universe itself. With this complete and total fluency, the very fabric of reality would begin to unfold its secrets. The doors to discovery would not just be opened, they would be blown off their hinges. From the deepest mysteries of the quantum realm to the grandest cosmic ballets of galaxies, everything could be described, modeled, and perhaps even predicted with breathtaking accuracy. The potential for innovation would be limitless. This mastery would represent more than just a personal achievement. It would be a turning point for all of humanity. The tools to solve our most intractable problems in medicine, energy, climate, and beyond would suddenly be within our grasp. It's a journey into the power of pure reason, a thought experiment that challenges us to consider the absolute limits of human potential and what lies beyond them. So let's embark on this odyssey together and explore what might happen if one of us mastered all math. They say that mathematics is the language of the universe. If that's true, then mastering it would make you the ultimate cosmic poet, able to read and write the story of reality itself. Every phenomenon, from the gentle fall of a leaf to the violent cataclysm of a supernova, is governed by mathematical principles. With a complete command of this language, you wouldn't just observe the cosmos, you would understand its deepest grammar. You could model the intricate dance of celestial bodies with a precision that makes our current astrophysics look like a child's sketch. The swirling chaos of a galactic merger, the invisible architecture of dark matter, all would become as clear as a simple equation. Think about the most enigmatic objects in the universe. Black holes. Places where space-time is so warped that our current understanding, our general relativity, breaks down at the singularity. With total mathematical knowledge, you could perhaps resolve this conflict. You might formulate the equations that seamlessly unite the world of the very large with the bizarre rules of the very small, quantum mechanics. You could peer beyond the event horizon, not with a telescope, but with the sheer power of a perfect formula, describing what happens in a realm from which not even light can escape. The universe would have no place left to hide its secrets. This power extends to the subatomic world as well, the probabilistic haze of quantum mechanics, where particles exist in a superposition of states until measured, could be described by an underlying mathematical framework we haven't yet discovered. You could predict the behavior of quantum systems with absolute certainty, not just probability. The fundamental forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, might finally be united under one elegant, all-encompassing mathematical structure. A true theory of everything would no longer be a distant dream, but a known truth, written in the language you now speak fluently. The digital world we've built, the world of artificial intelligence and supercomputers, rests entirely on a foundation of mathematics. Our algorithms are just sequences of logical steps, clever recipes for processing information. But imagine having access to the entire cookbook of mathematical possibilities. You could design algorithms of such elegance and efficiency that they would make today's machine learning models look primitive. The limitations we currently face in AI, the massive data sets, the immense energy consumption, the black box problem where we don't know how an AI reaches its conclusions, could be systematically dismantled. With a complete grasp of mathematical structures, you could create learning systems that don't need to see a million pictures of a cat to recognize one. Instead, they could understand the abstract concept of catness from a few examples, much like a human child does. This would lead to a new form of artificial intelligence, one that is not just a powerful pattern matcher, but a genuine problem solver, capable of abstract reasoning and true creativity. It could write symphonies, prove new mathematical theorems on its own, and design scientific experiments that we humans haven't even conceived of yet. This revolution wouldn't be confined to software. Your insights would transform hardware itself. You could pioneer new computational paradigms beyond binary, perhaps leveraging the complex mathematics of quantum mechanics to build flawless, stable quantum computers. Or maybe you'd invent something entirely new, a form of computation based on topological shapes or abstract algebraic structures. The very definition of computing would expand, allowing us to solve problems that are currently considered impossible, from simulating the entire human brain in real time to designing new materials atom by atom. The digital age would give way to a new, unimaginable era of computation. The global economy often seems like a chaotic, unpredictable storm. It's a massively complex system driven by billions of individual decisions, political shifts, and random events. We try to model it, to find patterns in the noise, but our forecasts are frequently wrong. Now arm yourself with a perfect understanding of statistics, chaos theory, and game theory. Suddenly, the storm begins to look less random. You could construct mathematical models of the economy with a level of detail and predictive power that is simply unprecedented. You would see the hidden connections, the feedback loops, and the tipping points that no one else can. You could forecast financial markets not by guessing, but by calculating. The subtle fluctuations of stock prices, the ripple effects of a change in interest rates, the boom and bust cycles that have plagued societies for centuries, all could be mapped out with astounding accuracy. This isn't about a get-rich-quick scheme. It's about understanding the very mechanics of human commerce on a global scale. You could predict economic downturns years in advance, allowing governments and institutions to take corrective action and prevent widespread hardship. The invisible hand of the market would become visible to you. Beyond the markets, this mastery would apply to the fundamental challenges of resource management and distribution. You could create perfect logistical models to eliminate famine by ensuring food gets where it's needed most, with no waste. You could design fair and stable economic systems that optimize for human well-being, not just growth. You could model the long-term economic impact of climate change with such clarity that it would end all debate and spur immediate, effective action. You would hold the mathematical keys to creating a more stable, equitable, and prosperous world for everyone. Every great engineering marvel, from the pyramids of Giza to the International Space Station, is a testament to the power of applied mathematics. But, our ambitions are often checked by the limits of our calculations. Materials fail, structures buckle, and systems break down because of tiny, unforeseen flaws in our mathematical models. With total mathematical mastery, though, these limitations would just vanish. You could calculate the stresses and strains on any structure with perfect precision, eliminating the very concept of an engineering bottleneck. The line between science fiction and reality would blur and then disappear entirely. Imagine the structures you could build, megastructures that dwarf anything on Earth today. A space elevator, stretching over 100,000 kilometers from the planet's surface into orbit, becomes a solvable engineering problem. You could calculate the exact material properties needed for the cable, the precise dynamics of its ascent, and the stabilization systems required to keep it standing against atmospheric and orbital forces. You could design cities that float on the oceans or are suspended in the clouds, perfectly integrated with their environment, self-sustaining and resilient. These would not be dreams, but blueprints waiting to be built. And this power, it would extend to the microscopic scale as well. You could finally create perfect quantum encryption, a communication system that is not just difficult to break, but mathematically impossible to crack, guaranteed by the fundamental laws of physics you now fully comprehend. You could design new materials with properties tailored to any need. Superconductors that work at room temperature, alloys that are as light as plastic but stronger than steel, or metamaterials that can bend light to create true invisibility cloaks. The world around you would become a canvas, and mathematics, your brush to engineer the impossible into existence. For centuries, mathematics has been haunted by great unsolved problems, enigmas that have resisted the efforts of the most brilliant minds in history. These are not just intellectual curiosities, they are locked doors, and behind them lies a deeper understanding of reality. With your complete knowledge, you would hold the master key. Consider the Riemann hypothesis, a conjecture about the distribution of prime numbers that has stood for over 160 years. Its solution would have profound implications for number theory and cryptography. For you, the proof would be self-evident, a logical consequence of the structures you now perceive. Then there is the P versus NP problem, a question that lies at the heart of computer science. It asks whether every problem whose solution can be quickly verified can also be quickly solved. If P equals NP, it would revolutionize everything from logistics and drug discovery to artificial intelligence. If P does not equal NP, it would define the fundamental limits of computation. You would not only know the answer, but you would understand why it is the answer, providing a final resolution to one of the most important questions of the modern era. The foundations of computation would be laid bare before you. And perhaps most profoundly, you would turn your gaze to the ultimate prize in physics, a unified theory. The disconnect between general relativity and quantum mechanics is a mathematical problem at its core. You would see the path to unification, the elegant set of equations that describes all physical laws. You could answer questions we barely know how to ask. What is the nature of time? Why is there more matter than antimatter? What happened before the Big Bang? The great unsolved mysteries of the cosmos would become solved chapters in the Book of Knowledge, a book that you have finally, completely read. What does it mean to be intelligent? We often measure it through logic, pattern recognition, and problem solving, all domains where mathematics reigns supreme. If a mind could contain all of mathematics, it wouldn't just be more intelligent in a quantitative sense, it would represent a qualitative leap in the nature of cognition itself. Such a mind would perceive the world through a lens of profound logical clarity. It could see the hidden mathematical structures in everything, in a piece of music, in the branching of a tree, in the flow of a conversation. This would be a new state of consciousness, a new way of being human. This transformation would inevitably reshape education and human development. How would you teach a child if you understood the perfect, most efficient pathway for knowledge to enter their mind? You could design educational systems that are not based on rote memorization, but on the cultivation of deep, intuitive understanding. You could tailor learning to an individual's cognitive architecture, unlocking the latent potential within every person. The gap between the math person and the arts person would dissolve, as you reveal the underlying mathematical beauty in all fields of human endeavor. Ultimately, a complete grasp of math might push human cognitive abilities into uncharted territory. Our brains evolved to navigate the savannah, not to contemplate infinity. Mastering the language of the infinite could trigger a new stage in our cognitive evolution. Would this lead to new forms of thought that we can't currently imagine? Could it unlock new senses, new ways of perceiving reality beyond our 5 biological ones? It's a staggering thought that by conquering the most abstract of sciences, we might not just be learning about the universe, but fundamentally upgrading the tool we use to understand it, the human mind itself. We've journeyed to the highest peaks of intellectual achievement, imagining a mind that holds the entirety of mathematical knowledge. We've seen how this power could unlock the universe, reshape our world, and redefine our very intelligence. But here, at the summit, we encounter a fascinating paradox. Mathematics is not a static, finished book of facts. It's a living, breathing, and constantly growing entity. New theorems are proven, new fields are born, and the scope of what is known expands every single day. The mathematical universe is itself infinite. So, could a person ever truly complete it? Or would the very act of mastering all known math give them the tools to instantly create new math, pushing the horizon of knowledge further away the moment they reached it? It's like trying to run to the edge of your own shadow. This suggests that the ultimate mastery might not be a final destination, but the beginning of an infinite, self-propelled journey of discovery. The reward for climbing the mountain is not the view from the top, but the realization that there are endless new mountains to climb. This leaves us with a final, profound question to ponder. If such a feat were possible, would this mathematical mastery bring a sense of ultimate knowledge, of finality and completion? Or would it be the ultimate lesson in humility, revealing that what we thought was the ocean of knowledge was merely a single drop in a much larger, truly infinite cosmos of understanding? Would it be an end, or would it simply be another stepping stone towards something even greater, something we can't yet even imagine? The quest for knowledge, it seems, is the true destination.